15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello, and thank you again for joining us on Space Nuts, where we talk astronomy, space science, and anything else interesting that's happening in heaven and here on Earth. My name is Andrew Dunkley, your host, and this week we're going to be looking at a little bit of a moon mystery. The moon's magnetic field has made the news, so we'll have a look at that. A gigantic exoplanet has been found under unusual circumstances, is the way I read this story. And we got a listener tip the other day, which we're going to follow up. There's a bit of a search on for a Falcon Rocket body, and they think it might have crashed into the moon, and they're asking amateur astronomers and space photographers to maybe provide some information that might help them find it. So we'll tell you about that a little later, and thanks for sending that in. And questions, surprisingly, about the James Webb Telescope and the James Webb Telescope and the Oort Cloud, and a couple other things we're going to chuck in for free on this week's episode of Space Nuts. Joining me, as always, of course, is his good self, Professor Fred Watson, astronomer at large. Hello, Fred.
Hi, Andrew. How are you doing this morning?
I am quite well, thank you, sir. Survived 35 years of marriage, so yes, all is well.
Congratulations. That's an achievement, that.
Yes, that was, we had our anniversary this week, 35 years. We both woke up and went, 35 years, really? It just doesn't feel that long.
No, that's nice. It's good. Well, you're still in love and still you young folk.
I never said that. Yeah, of course we are.
Yes, of course.
No, it's lovely. We went out for dinner and
lovely,
and just sat there and sort of pondered our 35 years and wondered where it all went. And yeah, we'll push on for 35 more. Not sure we'll get that.
I think
we'll give it a crack.
Yep. You've got a few youngsters around to demonstrate where it all went, though.
That's very true. Yeah, 4 grandchildren.
Yeah.
Now, as of November.
Yeah.
Now, Fred, let us get down to the business of talking astronomy and space science, and we are looking at the mystery of the moon's magnetic field, and I'm gathering from just glossing my eyes over this story that this sort of is something they've analysed through historic samples, historic data. Is that right?
Yeah, indeed. It's from the Apollo mission sample returns back in the 1960s and 70s. Let me see if I can remember the number. I think it was 387 or thereabouts kilograms of material came back from the moon. It's
which is why it's moving away from us, because it's so much lighter now.
It was. That's right. Yeah, it's a significant amount that was brought back. I might have that number wrong, but it's usually in my head, but it's a bit vague at the moment. It's there, that sort of order anyway. So that material was brought back and has been, in many ways, it's one of the greatest scientific treasure troves that we've ever had, because it's taught us so much about not just the moon and its origin, but the origin of the Earth and indeed the origin of the solar system. It's been absolutely fantastic.
What number did you say?
I said 387.
382.
All right, that's not bad. Maybe I'm not losing
pretty good.
As much as I thought.
A 7 can look like a 2 sometimes.
Yes, that's right. Yeah, that's good. Oh, thanks for that. That's cheered me up no end. So now the bottom line is that the moon doesn't have a magnetic field today. That's one of the things that's been known since the early days of the space age. In contrast with the Earth, which has got a fairly substantial magnetic field, the moon doesn't. But some of those rock samples that have been brought back have evidence within them that tell you that they formed in the presence of a strong magnetic field, one that, in fact, probably comparable with the Earth's magnetic field. So that's really interesting because, well, first of all, there ain't a magnetic field now. So what happened to it? But secondly, you've got evidence that from the rocks formed in the presence of a magnetic field and a strong magnetic field, how does a body the size of the moon, a quarter of the diameter of the Earth, 1/80th of the mass of the Earth, how does a body that size generate a magnetic field as strong as the Earth's magnetic field? And that's the big mystery. That is, well, number one is, where's the magnetic field gone? Number two is, how on earth did you manage to demonstrate, to actually, for the moon to produce a magnetic field that strong? Now, this has created a 50-year-old mystery, and it now seems to have either, well, I think we could say it's been resolved, but probably what a better way of putting it is that there is a new explanation that has been proposed for this magnetic mystery, and it comes from scientists at Brown University in the USA. So essentially, what these scientists have done, and actually there's one of the lead authors is also from Stanford University, just to get the attributions correct. What they've done is looked at models of the moon's internal structure during its early history, and it seems that you could get a situation where rocks, if you think of the moon as having a core and a mantle, which is what the Earth has got. The Earth's got the same sort of structure, and the mantle is that region where the rock is fairly soft and moves around by convection. And in the Earth's case, that causes the plate tectonics, because it's the convection within the mantle that provides the energy to drive the shifting continental plates and oceanic crust. So plate tectonics is driven by convection in the mantle. So if you think about that, the way these flows of magma go up and down in the mantle, but think about it in the moon. They've come to the conclusion that there are bodies of rock, sort of semi-liquid rock, which can move through the interior of the moon relatively quickly, and by doing that, generate magnetic fields. And partly that's due to some of the materials within them. Things like titanium, which are actually within these rocks, a high density of titanium, so that's a metallic thing. And that, intuitively you can, certainly for somebody who's a non-expert on this sort of thing like me, I can get the impression that might churn up some magnetic fields. But there's details in this study that really lead them to have I think a fairly high degree of confidence that this is going to produce the kind of magnetic fields that have been observed. So I'm just trying to find a quote from one of the authors, which this actually is Alexander Evans, who's at Brown University, as I mentioned. And Alexander says, everything we've thought about how magnetic fields are generated by planetary cores tells us that a body of the moon's size should not be able to generate a field that's as strong as Earth's. But instead of thinking about how to power a strong magnetic field continuously over billions of years, maybe there's a way to get a high-intensity field intermittently. Our model shows how that can happen, and it's consistent with what we know about the moon's interior. And it is all about these churning, blobs of material going up and down in the moon's mantle, the region around the core. They suggest that these are actually as small as 60 kilometers in diameter. And these are the titanium formations I mentioned before. And they sink over the course of about 1 billion years. So, it's not a fast forward thing. It's a relatively slow process. But what they suggest is that when these blobs of material hit the bottom, and by the bottom they mean the moon's core itself, then they basically stir up what is called the moon's core dynamo, and that's presumably because the moon has a metallic core. They stir that up, and generate these high magnetic fields for a short period. Partly because the things that are the blobs of titanium-rich material that are flowing down are much cooler than the core temperature of the moon, and so there's a sort of bang when this happens, generating a magnetic field at the surface that is really strong, like the Earth's. And they suggest, here's a comment from one of the other authors in this paper. You can think of it a little bit like a drop of water hitting a hot skillet. You've got something really cold that touches the core, and suddenly a lot of heat can flux out. That causes churning in the core to increase, which gives you these intermittently strong magnetic fields. And as many as 100 of these downwelling events over the moon's first billion years have been postulated, and each one could produce a magnetic field that might last 100 years or so. And so that's where these magnetic signatures come from in the Apollo rock samples. And one other thing that perhaps, in a sense supports this theory is that some of the other rock samples that came back with the Apollo astronauts show no evidence of having a magnetic signature. There isn't the alignment of grains that you find when there's been a strong magnetic field.
I was going to ask you how they can figure it out by looking at the rocks, but you just said
yeah, that's right. Sorry, I meant to mention that right at the start of this, Andrew.
No, that's okay. I would have asked.
Well, you did. So it's all about the alignment of the grain structure in the material.
Okay, yeah, that's fascinating. I suppose when you think about it, rocks tell us a lot of things, like rock samples on Mars are going to tell us about water presence and perhaps former life. I think geology plays a very big role in us understanding how things were over periods of time that we didn't even exist as a species.
Yes, well, that's right.
And that's fascinating.
One of the other things, just a bit more closely related to what we're talking about, though, that it's rock samples from beneath the ocean bed that tell us about magnetic reversals on the Earth's magnetic field. The fact that we know that every, maybe 2 or 3 times per million years, the Earth's magnetic field swaps, so the north magnetic pole becomes the south.
I've actually seen a rock like that, and what had happened was that somebody had drawn an N at the top of it, and then they'd scribbled it out and drew an N at the bottom. So I knew that
what had happened.
That's what had happened. There'd been a reversal.
That's what you call a magnetic pole reversal.
That's right.
Probably a slight reversal of logic there as well, but never mind. Never mind.
Yeah, plenty of that at my end. Yes, indeed. Okay, so it looks perhaps like they may have solved the mystery of the moon's magnetic field.
It's a very nice piece of work, I think, and well done to the scientists at Brown and Stanford who've done that work. Fabulous.
Yes, indeed. Wonderful. You're listening to, and if you're on YouTube, watching Space Nuts. And it's good to have your company. Andrew Dunkley here with Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, I did mention YouTube, and if you do have a YouTube account or you like to get onto YouTube occasionally and see what's going on, we do have an official page. It's youtube.com/c/Space Nuts. I'm sure if you just did a YouTube search for Space Nuts, you'd either get that really terrible sci-fi movie, which was called Space Nuts, or you would find us. If you put Space Nuts podcast in, you got a better chance. But all our episodes are there. And of course, the more recent ones are in fact showing our faces. That's pretty scary stuff. But if you can tolerate that, you can catch all the Space Nuts back catalogue on YouTube. We've got nearly 2,000 subscribers there, Fred, believe it or not.
Wow,
which is,
that's fantastic.
Which is fantastic. Only 100 million more, and they'll start paying us $1 a week. Apparently. If you'd like to join us on YouTube, just have a look around for us, and we'd be happy to have you add to the 1.95 thousand people that are already there. Okay, Fred, a gigantic exoplanet has been found under unusual circumstances. Where is it? What is it? And who found it? And why is it unusual?
Well, it's
in 20 words or less.
20 words or less. Well, I might quote Paul Delber, who is, I hope I'm pronouncing his name correctly. He's an astronomer at University of California, Riverside. This is probably more than 20 words, but it's very succinctly explains why this object, whose name is TOI 2180b, why it's important. He says, TOI 2180b is such an exciting planet to have found. It hits the trifecta of 1, having a several hundred-day orbit, 2, being relatively close to Earth, 379 light years is considered close for an exoplanet, and 3, us being able to see it transit in front of its star. It is very rare for astronomers to discover a planet that checks all 3 of these boxes. That's more than 20 words, but that highlights.
That's fine.
Yeah, it's a big planet as well. 261-day orbit around its parent star. It's a planet whose diameter is roughly the same as Jupiter, but actually 3 times more massive. And in fact, it's unusual because it contains 105 times the mass of the Earth in elements heavier than helium and hydrogen. That means it's a very, what we in astronomy would call a metal-rich planet. Astronomers call a metal anything that's not hydrogen and helium, and that's one of the loony things about what we do.
That doesn't necessarily mean solid.
No, and it doesn't mean iron or platinum or anything like that. It also includes sodium, and sodium is a metal, but beg your pardon, it includes oxygen, and they're all metals to an astronomer. For reasons that I don't need to go into now. Anyway, it's really metal rich. But why is it, a spectacular discovery? And why is it an unusual team that has found this? And it is because, the TOI tells you that it was discovered by the TESS planet finding spacecraft. Was it Transiting Exoplanet Survey Satellite? I think that's what the acronym stands for. TOI stands for TESS Object of Interest, I think. And so it was discovered by this planet having been observed to pass in front of its parent star and dip the light of its parent star slightly. And that's what TESS does. It's what Kepler used to do as well. And it's been a very, very successful way of finding exoplanets by what we call the transit method, sometimes called the wink method. I came across recently, which is a really
that's a good name for it.
Yeah, it's the wink method, which contrasts with the other method of finding planets, which is the wobble method, the Doppler wobble, where you look for the reflex motion of a star caused by a planet pulling it slightly from side to side. And the reason I mentioned that is because they've brought that method to bear on this object. So the reason why it's unusual is that when TESS finds a candidate planet by the light of its parent star dimming slightly, that is not something you can announce as being a planet, because there might be other reasons why that star's light would dim. Could just be a fault in the instrument or something like that,
or dust.
Dust on the lens, the whole thing. But no, it's not dust on the lens. Never mind.
The lens cap.
Yeah, the lens cap. So when the TESS research team look at their data, single events are not exciting because that needn't necessarily be a planet. And so usually what they have to do to count as a discovery is see this planet pass in front of its parent star 3 times. So they need to see 3 of these transits before it's confirmed as a planet. And that's perfectly sensible because, that you've then got an idea of what the period of revolution of the planet is around its parent star. And you've got 2 estimates of that. And if they tie up together, then, you found the right thing. If you think of something in our solar system, like somebody looking towards our solar system, every year they'd see a very slight dimming as the Earth goes past.
Yeah.
Now,
if they looked at Earth directly, they'd see a lot of dimming.
Yeah, they would. Oh dear, yes. Anyway, we won't go there. We're staying cheerful on Space Nuts this morning. So one of the numbers that I've already mentioned should suggest that this thing probably hasn't been observed 3 times, because it takes nearly a year. Well, 2/3 of a year, 261 days to complete a journey around its star. So it's what happened was that there are other groups who look at TESS data, and these are essentially citizen scientists groups who have access to the TESS data and look through it basically manually, rather than leaving it to a computer to look for these dips in the light of a star. These folk look through it manually because they can pick up things that you don't see, that the computer would not detect. And a gentleman called Tom Jacobs, he's a member of one of these groups. He's a former US naval officer. He basically, looking through the data, saw the light of star TOI 2180 dim, and he got in touch with Paul Dalber, who we've mentioned before, and that essentially started this research, because Paul Dalber's speciality is studying exoplanets that have long orbital periods. In other words, they take a long time to orbit their stars. So that's a very nice symbiosis. So Dalber, being a professional astronomer, could alert the astronomical community to try and, first of all, get an idea of whether this is a real planet by looking at the wobble method, which is where you look at the way the star behaves because of the gravitational pull of the planet on it. And that's what has allowed the calculation of the mass of the planet, TOI 2180b, and, gives you some ideas of its orbit. Now, the second transit has not yet been observed, I think. There was basically a suggested one possible in August last year. And there is a suggestion that there will be another one coming up sometime in February. I think that what this is implying, Andrew, is that this is not a circular orbit, that this is a fairly elongated orbit, which has probably come from the wobble data. So because August to February isn't 261 days. No, maybe it is actually. Well, it's not. It's not.
Couldn't tell you.
No, it's not.
Not off the top of my head.
It's shorter. It's shorter than that. So it suggests that this has got an elliptical or elongated orbit. So the planet has been confirmed to exist because the wobble method has proved that, and it's got all these apparently really interesting attributes, as we've said, a giant planet. In fact, one headline is a giant planet hiding in plain sight. And so I think it's a very exciting, an exciting object to be looking at, because it is so unusual. And so when there is another transit, that will allow more data on the orbit to be detected. People are actually looking for it already, or they will, certainly will be around the end of February. All credit to this group of citizen scientists for flagging this. I'm a great fan of
that's fantastic.
Science. Yeah,
really is fantastic. And it must be a delight to be able to actually have potential confirmation in such a short period of time, because I'm sure Paul gets frustrated when they discover an exoplanet and then they realise it'll be 500 years before we get the second transit. Right. And he's got to leave a note for his great grandchildren so that they'll have to check for him.
Well, it could be. That's right. You're talking about, it's when you think about the outer planets of the solar system, Neptune's 200 and something years. I can't remember the exact number.
Yeah, it's extraordinary. Yeah, that's a great story. Now let's move on to another search, and this one came from a listener who picked it up on a forum website, the cloudynights.com website, and they're looking for a Falcon rocket body, and they're looking again to citizen astronomers to help them out with this. I think this is a really good thing that people can get involved in.
That's correct. It needs a bit of careful observation. I think this is one for the amateur astronomers in the community. But this is an object. It's NORAD, which is the categorization of artificial objects in space. Its number is 40391, and apparently it's a Falcon rocket booster from earlier this decade, probably actually last decade, a few years ago. Falcon, remember, is the SpaceX's flagship boosters. Nowadays they bring them back to Earth, but a few years ago they didn't. And it's in orbit around Earth, but it's been gravitationally interacting with the moon, and it's objects like this often enter chaotic orbits. They because they're very lightweight objects. They're at the whim of the gravity of the moon and the Earth and the sun and the other planets. They often change. Their orbits are often not elliptical. They're elliptical for a little while, and then they change into something else, and then they go back to being elliptical. But now there is a chance that, first of all, the interactions with the moon have essentially sobered up the orbit of this object and given it a more predictable orbit. This is 40391, the Falcon rocket body. And there is now a chance that it will collide with the moon. In fact, in March, in a bit more than a month, about a month and a half, early March this year. And so that's a really interesting speculation. It's not something that we could ever observe because it's on the far side of the moon. But it would be great to know if this is going to happen. And so this alert on the Cloudy Nights Forum, which is a very well-respected, astronomy forum, that alert is for amateur astronomers who've got the capability to do astrometry, which is measuring the directions of objects very accurately, to try and observe it. When it is in a position where it will be reasonably bright, in other words, when it's sort of if you like, in opposition, in other words, on the opposite direction from Earth to the sun, so that you see it brightly illuminated by sunlight. It's easy to find if any of the amateur astronomers on the Space Nuts forum feel like going to Cloudy Nights, Google Falcon rocket body possible impact, and I'm sure you'll bring it up, because that has an ephemeris, at least a generator for an ephemeris. What's an ephemeris? That's a table that tells you where the object is going to be at a given time. It's a very old term, but it's still widely used in astronomy. And so it would tell you where to point your telescope. So during January and February, amateur astronomers are being alerted to do this. And any Space Nuts astronomy enthusiasts who've got the wherewithal to do it are encouraged to check it out.
Wouldn't it be awesome if one of our people did actually locate it and gave, NORAD went, oh, it was a space nut that did that.
It would, yeah, absolutely.
Yeah. All right. Just do a general search. You should be able to find it, or go to the cloudynights.com forum website and look for it there. The URL here is 300 miles long, so I won't read that out because you have a bit of trouble remembering it. But, it shouldn't be hard to find. Maybe NORAD would have something on their website after they've sent the boys over to check out you're okay to use their website. But yes, good luck with that. Let us know how you go if you have a crack. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.